Use the inverse matrix method to solve the following systems of equations. And we have 3x plus 2y is equal to 33. And we have 5x minus 7y is equal to 7. That is negative 7. So we are told to use the inverse matrix method. The inverse matrix method, sometimes you can be asked to just use the matrix method. So the matrix method of solving simultaneous equations, let's have our solution. We have 3x plus 2y is equal to 33, and we have 5x minus 7y is equal to negative 7. In this case, we have to extract the coefficients of x and y to form matrices. So we shall have 3, 5, 2, negative 7. Then we follow by xy, and this should be equal to 33, negative 7. Then after that, what you do, you find the inverse of this matrix and you multiply with the inverse both sides. So the first thing is to get the determinant of the matrix. Determinant of the matrix is given by the product of the principal diagonal minus the product of the other diagonal. So the determinant here will be 3 times negative 7 minus 5 times 2. And when you subtract these two, you are going to get negative 31. So negative 31 is the determinant. The inverse of our matrix, we take 1 over determinant, which is negative 31, and we multiply with, we exchange the values under the main diagonal, and we change the signs of the other values. So we shall have the inverse as negative 7, then negative 5, we change the values of the signs, then we exchange main diagonal where we have negative 7 and 3 on the lower end. So this is the inverse. Then this inverse, we shall multiply it both sides of this equation. So we shall have our 1 over negative 31, which is the inverse, negative 7, negative 5, negative 2, 3. We multiply with 3, 2, 5, negative 7, xy, and this should be equal to the same inverse. We have negative 7, negative 2, negative 5, 3 times 33, negative 7. 33, negative 7. So when you reach that step, there are things that you have to know, that when you get any matrix, for example matrix A, the inverse of A times A, you get an identity, which means when you multiply this, you are going to get an identity matrix. And also, when you get the identity matrix and you multiply with any matrix, you are going to get, let's say matrix B, you are going to get 1. So what does this tell us? When you reach at this stage, when you multiply identity matrix with any matrix, you get the matrix itself. So this tells us that When you reach at this point, there is no need of multiplying out, so you simply get xy, because this matrix times its inverse, you'll get identity. The identity times this matrix, you'll get the matrix itself. So in this case, we shall get xy on the left hand side, and this now will be equal to our right hand side, which we'll have to multiply to get the value. So let's multiply this matrix and this matrix, then finally we multiply with our 1 over negative that 1. So matrix multiplication, you multiply every row of first matrix with every column of the second matrix. So the second matrix has one column, so we shall have to multiply negative 7 times 33 plus negative 2 times negative 7. Then we move to the second row, we multiply with the column also. So we shall have 1 over negative 31 negative 7 times 33 plus negative 2 times negative 7. Then the second element will be formed by negative 5 times 33 plus 3 times 7 negative. When you compute this, you will get, xy being equal to 1 over negative that 1. When we add these products, we shall get negative 217 and negative 186. Let's multiply this matrix with our 1 over negative that 1. We shall have xy being equal to, when you multiply here with 1 over that 1, negative times negative 217, we shall get 7. And when you multiply with negative 186, you get 6. And from matrix equality, this will give us x being 7 and y being 6. And these will be the solutions for our equations using the inverse matrix method.